So this is a reminder that you guys have some flexibility in terms of how I calculate your grade at the end of the semester. On the test that I will give back for good next time, I calculated your average according to the standard grading rubric, and that's fine if you want to keep it that way. But if you want to go test heavy, you can opt for that. If you want to go test light, you can opt for that. You can also make something that is really geared towards how you think you will do the best this semester. So you all have a test grade that presumably will go up if you do test corrections. So on Wednesday, I'm going to ask you to fill in and tell me whether you're going with one of the three basic options or your own personalized thing, okay? This information is on the syllabus. So part of what you want to do between now and Wednesday is make a choice about how you want me to grade you, okay? Scratch that. I'm going to ask you to make this choice for Friday because I want to give these tests back to you Wednesday so that you have all the numbers in front of you. You know what your homework grade is, what your quiz average is, what your project average is, okay? So I'll ask for this on Friday from you. All right. Okay, so our quick look at the calendar tells us that we just had our first test, and we're now entering basically the second third of the semester. You'll notice that there are going to be some pre-calc review days in here, kind of sprinkled in with the calculus. So the composition of functions is a topic you've seen in pre-calculus. Exponential functions, another standard pre-calc topic. Trig functions, like really on these days, we're not, and there's inverse and log functions. We're not doing any calculus on those days. We're just going to review some of the pre-calculus stuff, which will give you a good time to kind of absorb the calculus from the previous day. And we put these pre-calc review days right before the calculus days that require them. So the trig functions day is there, and then the derivative of trig functions is the next class after the project check-in. So on page 1 is a derivative formulas reference sheet. You should be happy to know that you're going to be able to use this thing on the test, second test, also on the final exam. So we're going to skip past that and move on to page 3. And we'll start with our daily summary on page 3. Ryan? Composite. Okay, so I'm just going to point out in number 2 that the third and fourth projects are officially assigned as of right now. Make sure you have one of each. They kind of look quite similar on the first page, so really make sure you have one of each and not two of the same. They actually have their titles at the top, I think. So those are due in about 3 weeks. The dates are on the syllabus calendar. But as usual, there's a suggested timeline. And really, you have most of the tools already to do most of the projects. So I'd encourage you to try to stay on top of those. Okay, we'll jump down here to number 4. Isaac? Keep going. Okay, so f of g of x. Isaac read that exactly right. I know that when we compose functions, we work from the inside to the outside. So instead of g of x, what can I put? 3x plus 1. Okay, because g of x is exactly the same as 3x plus 1. And then here's the harder part for a lot of folks, is to find f of 3x plus 1. So let's take a brief step back. F is the function that takes whatever you put inside of it and throws it under a square root symbol. Yes? F just takes the square root of whatever you give it. So what we're giving f in this case is 3x plus 1. Well, I know that f is supposed to take the square root of whatever I give it. What goes in there? So 3x plus 1. So that's the f of g of x. Okay. Part B. So suppose we have this function, h of x is x squared minus x plus 1, all to the 23rd. We're going to find two functions f and g, so that h of x is really f of g of x. So we want two simpler functions so that we can build up to that more complicated h function. So what would you say is the inner part of the original h function? X squared minus x plus 1 is inside, right? It's in the parentheses, just like something was under a square root. Which one is the inner function, f or g? G. So it seems quite natural to put x squared minus x plus 1 over here. That's the inside. And then if we kind of like, you know, cross your eyes a little bit so you really can't focus on exactly what's in there. It's just some stuff. And it's being raised to the 23rd power. So the outer function is going to be the function that takes some stuff and raises it to the 23rd power. What's the function way of writing that? X to the 23rd. It takes whatever, f is the function that takes whatever you give it and raises it to the 23rd power. Any questions on that? Okay, so let's move on to 5. Kyle? Keep going. All right, so there's the English version, which probably won't make a whole heck of a lot of sense if you've never seen this rule before. The symbol notation, I don't know if it's much better. Let's just jump in with some examples, and then we'll go back up and check the English and the symbols. So number 6, we'll go to Brendan. Okay, so let's try this first guy. Y is equal to the square root of 3x plus 1. So suppose that we were to rewrite this thing as 3x plus 1 to a power. What power would that have to be? 1/2. And if instead of something complicated here, this was just x to the half, then we know how to take a derivative, right? Half comes to the front, copy the x, subtract 1 from the power, right? So we're going to do that, even though it's not just x in there. We're just going to treat it like it's an ordinary x. So let's find our derivative here. So y prime equals, what comes to the front? 1/2. Then we copy what normally would be an x. In this case, it's a little more complicated, but we copy it just like we copy the x. And what's the new power? -1/2. Now, this isn't quite the right answer in terms of the derivative, but it's part of the answer. It's most of the answer. But does everybody at least see that that's a reasonable answer if we were just pretending the 3x plus 1 was the simplest thing it could be, which would be an x? So it turns out that this new rule says, well, just do your normal derivative, but then at the very end, it's underlined up here, multiply by the derivative of the stuff. The stuff in this case is what we were treating like an ordinary x. It was that. So all we need to do is tack on to the end of our derivative here times the derivative of the stuff. What's the derivative of 3x plus 1? 3. That's the answer. So this new rule is called the chain rule. It says you do your ordinary derivative, but then you multiply by the derivative of the stuff. Let's try part B. Y prime equals. It's the same idea. I see some stuff to the 23rd power. In fact, I'm even going to write stuff to the 23rd. So how should the derivative start? 23 comes down. And we copy all that just like it's an x, and then the new power is 22. That seems perfectly reasonable. That's what the derivative would have been if it was just x in the parentheses. But then this new rule says, well, that's not quite it. That's not the end of the story. You have to multiply. It's always multiply, not add or subtract. Always multiply by the derivative of the stuff. The stuff is this, and I need to multiply by its derivative. What's the derivative of x squared minus x plus 1? 2x minus 1. What do you think we're missing? We're missing something. It's parentheses. Right, because 2x minus 1 is one entity. It's one derivative. It's the derivative of the stuff. So that's our answer right there. Okay, so let's go back up, and we're going to have Kyle. Can you reread version 1? Okay, let's see if we did that. In part B, the outside function was raising to the 23rd power. So we took the derivative, 23x to the 22, but instead of x, Kyle just read, it's the derivative of the outside evaluated at the inside. So it's not x, it's whatever it used to be. It's this stuff that's circled in red. And then times the derivative of the inside function. And that's what's sticking out here. Now there's a couple of notation ways to write this too. Again, I don't know if they're going to be any better for you, but we need to be able to work with them. So this first one here, version 2, says you want the derivative of f of g. You find f prime, but it's not f prime of x. What is it? It's f prime of g of x. So you take your outside derivative, but you don't just stick an x in there, you stick the inner function in there. You just leave it in there. And then times g prime of x, that's what we've been calling the derivative of the stuff. And so that's written out less formally over here. Right? F prime of the stuff times the derivative of the stuff. And then Leibniz's notation in version 3, dy dx, that's his notation for the derivative. It's dy dz times dz dx. Okay, I'm going to read this parenthetical in a second. But if we just treated these guys over here as fractions, does it seem reasonable that this would be equal to dy dx? Like if it was just fraction multiplication, what could you do to simplify things here? Couldn't we just cancel the dz's and then we get dy on top and dx on? So like it's reasonable, at least fraction, the way it looks like a fraction. And the idea here is that y is a function of z. So y is your outer function and z is your inner function. And so I'm going to highlight some stuff. There's the derivative of the outer function in both. Here's the derivative of the inner function in both. Okay. I think that's good. One thing that isn't here in the notes, but Caitlin mentioned that she did earlier today, and I thought it was a great idea, was to point out that, for example, if we let y equal, I don't know, 3x to the 5th. Like the question is this new rule, this chain rule, like is it completely different from the basic power rule that we've known for a few weeks now? So what's the derivative of this? 15x to the 4, right? But what if you wanted to try to pretend that it was more complicated? If you wanted to treat it like one of these new things here. So I'm going to call that guy right there my stuff, which is just as simple as could be. It's x. So let's go ahead and take our derivative. Y prime equals. So it's what you just said, 15x to the 4, but then times the derivative of the stuff. What's the derivative of the stuff that's circled? Is 1. So this chain rule it captures what we knew already. It's just we never bothered putting this times 1 at the end, because if it's just plain x, you don't bother thinking about the chain rule. But the chain rule is this very general thing that applies any place you want. One other thing here is to avoid this very common mistake. Let's do this guy again, is to say y prime equals. So 23 we know, 22 we know, but it's really easy to make this mistake, is to kind of combine the two derivatives into one expression. You have to make sure you copy that stuff one time. You don't get to take the derivative of the stuff and jam it inside the function, okay? So I'm going to put a big old line through this. Do not do that. It's like an ordinary outside derivative times an ordinary inside derivative. Okay, so activity starts there. Let's see how far we can get.